There is an image that every owner of a brick building built before the 1920s needs to see. The cement mortar joints are pristine, in perfect condition. The bricks between them are crumbling, faces popping off, entire sections collapsing into rubble. The mortar was supposed to be the repair. It became the weapon. Before Portland cement existed, buildings were held together by lime mortar, a material that heals its own cracks, absorbs carbon dioxide from the air, and literally turns back to stone. It has lasted 2,000 years in Roman structures that are still standing today. In the 1920s, we replaced it with something faster and cheaper. Now that faster and cheaper material is destroying the buildings the original mortar kept alive for centuries, there is a good chance it is happening to your house right now. In January 2023, MIT announced the secret behind Roman concrete's durability of 2,000 years. Millions saw the headline. Almost nobody realized the same chemistry was already in their walls. Professor Admir Masick discovered that tiny white specks in Roman concrete, previously dismissed as sloppy mixing, were deliberate. These were lime class, reservoirs of reactive calcium embedded throughout the structure. When cracks form, water dissolves the calcium. The solution flows into the gap, and it recrystallizes as calcium carbonate, limestone. The concrete heals itself. In lab tests, cracked samples healed completely within 2 weeks. Control samples without lime class never healed. The chemistry is a perfect circle. Heat limestone to drive off carbon dioxide, and you get quicklime. Add water and you get calcium hydroxide. Mix it with sand and apply it as mortar. Over time, it absorbs carbon dioxide from the atmosphere and converts back to calcium carbonate. It becomes limestone again, the same rock you started with. This is not just Roman concrete. This is the exact chemistry of lime mortar, the material that held together every brick building in America before the 1920s. Every cathedral in Europe, the Pantheon, the Colosseum, the Great Wall of China. Lime mortar was used in construction for over 6,000 years before Portland cement was invented. Lime mortar was designed to fail. That is what made it work. The genius is counterintuitive. Lime mortar is intentionally softer than the brick it binds. Historic lime mortar has a compressive strength under 300 pounds per square inch. The soft brick it held together had a compressive strength of 800 to 1,500 pounds per square inch. The mortar is the sacrificial element. When stress occurs from thermal expansion, settling, or wind, the mortar absorbs it and cracks instead of the brick. When it eventually erodes, you repoint the joints. The bricks remain intact for centuries. Lime mortar breathes. It is vapor permeable. Moisture moves through the joints, not through the brick. No trapped water, no mold, no freeze-thaw damage. And when microcracks form, rainwater dissolves calcium at the cracked surface, migrates into the gap, and recrystallizes as calcite. The mortar heals itself. Scientists call it autogenous healing. The same mechanism MIT found in Roman concrete has been quietly working in the walls of your grandmother's house. In 1824, a bricklayer in Leeds, England, twice prosecuted for stealing limestone from public roads, patented a powder that would replace a 6,000-year-old material in barely a century. Joseph Aspdin called it Portland cement because the hardened product resembled Portland stone, the most prestigious building material in England. It set in hours instead of weeks. It required no artisanship. It came pre-mixed in bags that any laborer could use. A bag of Portland cement costs $8 at Home Depot. A bag of natural hydraulic lime costs $35 to $60 from a specialty importer. Natural hydraulic lime is not manufactured anywhere in the United States or Canada. By the 1920s, Portland cement had replaced lime mortar in American construction almost entirely. Speed won. Skill was discarded, and nobody asked what would happen to the buildings that lime mortar had been protecting for centuries. The strongest mortar destroys the building. Here is exactly how. Portland cement mortar has a compressive strength of 1,800 to 2,500 pounds per square inch. The original lime mortar in buildings from before 1920 had under 300 pounds per square inch. Portland cement is 6 to 10 times harder than the mortar it replaces. The sacrificial relationship is reversed. The mortar is now harder than the brick. When stress occurs, the brick becomes the failure point instead of the mortar. But hardness is only half the damage. Portland cement is impermeable. Moisture that used to escape through the joints is now trapped inside the wall, forced through the softer brick face. Trapped moisture carries dissolved salts to the brick surface. The salts crystallize beneath the outer skin. Water expands 9% when it freezes. The brick face pops off. This is called spalling. The cycle repeats every winter. The hard-fired outer surface of the brick is gone. The softer interior core erodes rapidly, and the cement joints remain perfectly intact. Pristine mortars standing proud, while the bricks between them crumble to dust. The National Park Service states it plainly in Preservation Brief 2. If the mortar does not permit moisture to migrate out of the wall and evaporate, the result will be damage to the masonry units. Thomas Jefferson's Capitol survived the Civil War. It could not survive Portland cement. The Virginia State Capitol in Richmond was built in 1783. It survived the bombardment of the city during the Civil War without significant damage. In the 1880s, the original lime stucco was replaced with Portland cement render. When investigators examined the walls, the brickwork behind the cement had spalled severely. The outer 20 to 30 millimeters of brick was crumbling or still attached to the cement when it was pulled away. But deep inside the 1.8 meter thick walls, the brickwork was pristine. Mortar and brick still crisp and sound after more than 200 years. Radar confirmed the outer brickwork was saturated through its full thickness. The trapped moisture had done what cannonballs could not. All Portland cement is being removed and replaced with lime. Mount Vernon, George Washington's home, was built between 1758 and 1778. It is currently undergoing a $40 million mansion revitalization project for one reason: to remove Portland cement from previous repairs and replace it with original lime mortar. The cement was far too hard for 18th century brick and stone and had been trapping moisture for decades, accelerating the degradation of the building it was supposed to protect. Two of the most important buildings in American history. Both survived centuries. Both are now being rescued from their own repairs. If your home was built before 1920, there is a good chance this is happening to your walls right now. In the United Kingdom, 5.9 million buildings were constructed before 1919. In the United States, roughly 35% of all buildings were built before 1945. Nearly all originally used lime mortar. Nearly all have been repaired at some point with Portland cement. Cliff Blundell of the Building Limes Forum calls it an epidemic of damage inflicted by generations of builders with no knowledge of how solid walls are intended to function. A Brooklyn homeowner paid $3,500 for cement repointing. 18 months later, freeze-thaw cycles caused catastrophic spalling. A parlor wall bulged inward. Water cascaded through original plaster. The emergency repair estimate was $52,400. A mason with 28 years of experience admitted publicly that until 3 weeks prior, he had no idea Portland cement could damage historic masonry. Heritage Building Inspector Bill Kibble has a standard response when a contractor blames the damage on inferior bricks. Do not blame the bricks. The mortar that is destroying these buildings costs $8 a bag and is available at every hardware store in America. The mortar that would save them is not manufactured anywhere on this continent. Natural hydraulic lime must be imported from France, Portugal, or Germany. It was not until 2013 that the U.S. standards body ASTM created a specification for NHL mortar in historic repair, 189 years after Portland cement was patented. No masonry training program in the United States teaches lime mortar as standard curriculum. The country has 294,000 masonry workers. The number trained in lime is a fraction of a fraction. The death killing cycle feeds itself. Portland cement requires no skill, so fewer masons learn lime. Fewer lime masons means lime knowledge disappears, and Portland cement becomes the only option available. Meanwhile, the global cement industry produces 4.1 billion metric tons per year, generating 8% of all human carbon dioxide emissions. If cement were a country, it would be the world's third largest emitter, behind China and the United States. Lime mortar absorbs carbon dioxide as it cures. Portland cement emits carbon dioxide. The knowledge is not lost. It is being rebuilt one wall at a time. The modern lime revival began in 1975 at Wells Cathedral in England, where Professor Robert Baker pioneered lime conservation on the 800-year-old West Front. 50 years later, the movement has spread worldwide. In the United States, Andy DeGruchy of Limeworks has spent 27 years restoring historic buildings with lime mortar, training certified installers, and consulting for the National Park Service. He describes the process with a kind of reverence. When rain and wind hit a lime-mortared wall, the joints actively attract carbon dioxide from the water and convert it back into stone. The wall is not decaying, it is still curing, still getting stronger. After a century, the National Park Service, the General Services Administration, and Historic England all now specify lime mortar for historic building repair. The Scottish Lime Centre Trust offers formal qualifications. Historic England launched a £4.325 million heritage building skills program to address the critical shortage of trained lime masons. A new generation of artisans is returning to the oldest method of all: hot lime mortar. Quick lime mixed directly with sand on site, the way it was done for thousands of years before bags of Portland cement arrived at hardware stores. The life cycle math makes the case on its own. Lime repointing at $15 per square foot lasts 50 or more years. That is 30 cents per square foot per year. Cement repointing at $8 per square foot lasts 10 years. That is 80 cents per square foot per year. Plus thousands of dollars in brick damage that lime would have prevented entirely. This is the third time we have told this story. The ingredient is always the same. Roman concrete self-heals through lime carbonation. MIT proved it in 2023. The Pantheon has lasted 1,900 years. Hempcrete, lime plus hemp hurd, gets harder every year. It survived 1,700 degrees for 60 minutes. The plant was classified alongside heroin for 81 years. Lime mortar, the same chemistry applied to every brick building in the Western world for 6 millennia. Self-heals, absorbs carbon, turns back to stone. 3 materials, 3 stories, 1 ingredient. Lime. And in every case, lime was replaced by Portland cement, a material that sets faster, costs less, and lasts a fraction as long. The pattern never changes. A material that works for centuries gets replaced by one that profits for decades. If your home was built before 1920, the mortar holding your bricks together may be the most advanced self-healing building material ever used in residential construction. It has been absorbing carbon dioxide and turning back to stone for over 100 years. It was designed to sacrifice itself so the bricks would survive. If the wrong contractor repoints it with Portland cement, that process stops. The bricks start dying instead. The mortar was never the problem. The repair is the problem. And the repair is happening right now to millions of buildings by people who have never heard of lime.